2025. What is gonna happen this year? First of all, I'd like to say thank you very much for all the encouragement I had speaking in front of the camera instead of the narration that I normally do. It's very nice of you to say. Thank you very much. I hope you don't regret it. Actually, you probably will. You probably will regret it. Actually, I can see the comments now. You're going to be, I'm sorry, we screwed up. We shouldn't have encouraged you to stand in front of the camera. Please go back to narration. So there's been some goings on with the project. Let's have a look, shall we? When changing the front engine mounts, it has come to my attention that the rear left has actually come away from its proper location. This would have happened during the dry shaft failure, and I've only just noticed it. This was one of the reasons the dry shaft alignment was so far out. I've just milled the slots in the dry shaft tube and drilled and tapped the 96 holes for the roller guides. I've chosen 832 UNC socket cap screws because that thread was the most coarse for that size. Coarse threads are recommended for threading into aluminium. I test fitted 2 roller guides with all the screws just to check for any problems and to see what it's going to look like. Of course, I had to see what it was going to look like on the machine too. The length of the screws is going to have to be reduced for clearance to the inner tube. Unfortunately, the size length below is too short, so 96 screws to cut and deburr them. Next is making the lower drive flange. Not much to that really. It's a nice tap-on fit to the tube and I've bolted it with 8 M4 bolts. Next is the top universal joint yoke, this time aluminium. I haven't made lots of video on how I made it because it's the same as the steel one I did. Really pleased how that's come out. That's really nice. Next thing to do is to drill and bore a hole right through the middle. I'll do that on the lathe, make the part light as I can. Then after I need to put some circlip grooves in here. So it looks like that. I had to think about how to do that. While I'm boring that out on the mill, perhaps you'd like to have a think about it and see what you come up with, but for now it's a bit tricky. There we go. Much lighter. I've gone for 5mm wall thickness. It's going to be bolts going right through the centre of that. Hopefully I can get a spanner in there to tighten up. I'm sure I can. And it goes on the helicopter here. That's quite nice. Well, I've given you all of 30 seconds to come up with a solution to the circlip groove, and this is my solution. I bought this woodruff cutter. It is 1.6mm wide, and I'm going to use the rotary table to machine this groove. The rotary table is in there, and it weighs enough to give me a hernia. Therefore, I might get the engine crane to lift this one out for me. Years ago, yes, I used to lift it around, no problem. But these days, if I attempt to lift that, I guarantee I'll have back problems for a few weeks. what I'll do is I'll make a spigot to go in the center of there, have a spigot to go in the center of there. That will locate it on the center line, and all I need to do is rotate it while I'm cutting. That's it. That's the grooves in the aluminium yoke and the grooves in the steel yoke. The next thing to do is to get this primary drive pulley assembled, and I've laid it out in order on the table. I've got the spider in the top part of the universal joint. Anybody that's assembled a universal joint knows that you have to press these bearings in with a vise or press. And that's the reason I haven't put this part on yet. I want to put this part on to check I've got the angle. This assembly procedure is a little bit tricky. I haven't designed it the best in terms of being able to take it apart and put it back together again. So I only really want to be doing this once. How it works is we'll start with this shaft, and then this bearing here gets slid over the shaft, and it's a very light press fit. Probably be able to do it with a bit of tube and a hammer to knock that down to that position there. The next thing to go on is this thrust bearing that goes against there, and then the bottom retaining plate. The next part to go on is the bottom of the belt guide, presses into the pulley, sits on top of there like that. Next thing to go on is these rings, and these are a press fit again, a bit tighter than the bearing, so they need to be probably pressed on one at a time in the right place. Then this pulley gets slid over those, the top belt retaining guide, top plate for the bearing, another thrust bearing, and finally the top bearing. And that is the complete procedure. However, there's a complication in that the belts need to be slid over the pulley during that assembly. I'm not even quite sure how that's going to work. I think there's going to be a way, it's just I haven't managed to work it out in my head how it's going to work. It's a bit like the main shaft. There is a procedure to assembling the pulleys to the shaft, and then all the bearings and the split bushes and all that kind of stuff. And I can't remember the procedure, even though I designed it. So it's quite useful to make these videos because I can look back later and say, oh, that's why I did it. There we go. All together. Drives in that direction, spins in that direction. Doesn't make sense. Drives in that direction, it's free to rotate in the other. And that's what all that complicated assembly was all about. Just to have that. Let me explain the plan. Right, so this goes on there like that, and these are 10mm holes, and these are 8mm bolts that I want to use. Therefore I need to make this little collar, and that will press into there and then slide into the other one, or something similar to that. I've raised this up a bit just to make sure there's no resistance to tilting. I just felt a bit happier doing that. Now what happens, I've got this CF53 rod, and that is going to go through there, and I did buy these needle rollers to go on the end, and they were going to slide in this slot like that. But I've changed my mind. These needle rollers are designed to be pressed into a hole, and they are slightly bigger than the actual stated size because it's supposed to be a press fit, and it compresses to the right size once it's pressed in. And I don't really think that is suitable for sliding up and down inside here when it's not being withstrained by a hole. Therefore, I've bought some phosphor bronze, and I'm going to machine the bronze to fit inside there, and that will be used instead of the needle roller. Next, so this is the tube that's going to slide inside here, and I'll drill holes for the CF53, that's hardened steel rod, to go through. I'm going to have a collar welded into this stainless steel, and then this rod will fit inside that collar, and it will be a sliding fit, not a press fit, just a sliding fit. I don't want any play in it. Now that's changed because originally I designed this, or my plan was to have an aluminium tube slide inside here, and I was going to have it thick walls, something like 6mm, and therefore the rod I was going to press into the aluminium tube without any kind of sleeve. Except a friend of mine, Andrew, pointed out to me that when you press this in, it will probably take some material out of the aluminium because of the difference in hardness, and you may end up with a slack fit. Therefore, I've changed that. And actually, aluminium being a third of the weight of steel, I can go to a 1.5mm wall steel, and it will be that'll be lighter than the blooming typical that is. The compressor goes off. Right, so third of the weight of steel. No, aluminium is a third of the weight of steel. Therefore, if this is 1.5mm wall, then is that 1.53, 4.5. Therefore, steel is going to be lighter than the thick wall aluminium that I've chosen. This isn't in place yet, but this is going to slide inside here, and that will be a loose press fit. Loose press fit? What the flip's that? It's either a press fit or it's a loose fit. There's no such thing as a loose press fit, you boob. I have bolts in the same manner as I've got down here. They're not threaded. Well, they're not tapped. They're bolts to go right through, and I'll be able to get a spanner on the inside to fasten that before it's pushed into the joint there with the needle rollers that clamp that in place. Is that everything? I think that's it. That is the plan. That is the new plan. It's changed slightly from how I was going to do it. But that's what happens. Things change and you go forward. Actually, I've just thought of something. Now the tube here and the rod, like I said, the sleeve welded into here, and I was going to just slide this in, but if I do that, then there's nothing to stop this shaft turning inside the sleeve, and I want the bronze to be the things turning. Therefore, I'm going to have to rethink that a little bit. Maybe I could have a grub screw in the sleeve. That's all right for this one, but you're not going to reach these up here. If I made it slight interference fit, that's fine, I suppose. I've already bought a reamer to be able to ream the sleeve, but if I ream it, it's going to be 0.02 clearance. Therefore, it's not going to be a press fit. Give that some thought. Before I cut the tube that slides inside here to length, I want to make an alteration. And that alteration is increasing the amount of pitch. Currently, it's set to 5.6 degrees of pitch and 6.8 degrees of roll. I've got that written down over there so I don't forget it. That's why I looked over there. I want to increase the pitch because I did hit the full forward cyclic stop last time, and I had a weight on the tail here to try and get everything balanced, but I still hit the forward cyclic stop. So I removed that tail weight, so that brings the fuselage nose heavy a little bit, and so I wouldn't need quite so much forward, and therefore I wouldn't hit the stop on the forward limit. But the reason it's 6.8 degrees in roll and 5.6 degrees in pitch is because I changed this hinge for a stronger design, and it contacts this tube here, and I need to modify that so you get more pitch. And to do that, I'm going to put a spacer between this hinge and the plate to raise it up so it doesn't contact this tube and gives me a little bit more. I think I only probably need the same amount of roll as I do pitch, and that will be enough, I would have thought. For those of you that are new to the channel, you won't see a helicopter controlled in this way. You don't see many coaxials, and normally they're controlled by swash plates, which controls the pitch of each individual blade as it rotates, and that's the control. But this is the same as a gyrocopter in that it just tilts the whole rotor, and there are negatives to doing it that way. The only positive really is the fact that it's simple, and that's the reason I went down this route. It's as simple as it gets, really, apart from this drive shaft, which I've had problem with. Increase in pitch from 5.6 to 7.3 has increased the travel on here, and it's gone from 50mm to 60mm, 10mm difference. I did allow for 90mm of travel in these slots, so that's fine with me. I've put some spacers in here for now so that I can test the articulation of this joint. From the 3D modelling I did, I got an angle of 5.25 degrees each side, so total of 10.5. So I'm interested to know if the 3D model is correct, and we're all good. Right, that's 0. You have 20 degrees, 10 degrees each side. That's good, even better. Let's turn it the other way then. And this way we have 22 degrees. Lovely jubbly. I've shimmed up the head so that is now level with the frame. And that's the way it should be when it's hovering. You should have everything perfectly balanced so that you're hovering with a stick in the middle. If it was out, too nose heavy or too tail heavy, it will still hover, but the cyclip stick will have less travel in whichever direction it is, according to whatever. That's our first position of the drilled hole. We can use that to tell where all the other holes need to go. Oh, my knees. All right. Okay then. Nice and level. Wonder if there's a better way. Nah. Really pleased with this. That's so nice. And it self-locates in the center. I didn't actually realize it would do that. I thought I'd have to rely on the length of the pin that goes through to self-center, but obvious really, but it self-centers just via the slots. Lovely. There's not a lot of play in this, despite, these are just bolts, but I'll be able to turn down the phosphor bronze bushes that go in here to get a beautiful fit. It doesn't go all the way down because the bolts here sticking out. They need to be slightly lower profile, and then they'll slide just inside that if I need it to, but I don't actually need that much travel at the moment. It's just maybe I will at some point. I just want to thank Freezertron for sending me an alternative dry shaft idea. It's not something I had thought of, and it's certainly worth some consideration. It just goes to show there are many ways to design this type of shaft, and each one has positives and negatives. For example, the first design Freezertron sent, he knew there would be a centrifugal force acting on the joint, which would move the joint lengthwise. To our surprise, the force that would act would be a few hundred kilograms. Amazing how much force can be generated due to the shaft speed despite a lightweight and small diameter. He then sent a few other designs to try and alleviate the lengthwise force. Calculating the exact force is tricky, but it may be possible to balance forces acting on the joint with springs. If for some reason my design doesn't work, then alternatives would have to be seriously considered. Here is another. I think this was a Volvo drive shaft, and the plunging is achieved with ball bearings running in groove slots. A vehicle drive shaft is under a lot of torque by comparison, and I'm surprised this design works. The dry shaft I'm making will be complete in the next week or two, and then I'll be able to start testing it. I'll run it up with no blades to start with, and then testing on my trailer with blades attached. There are a few things to address before any hovering can take place, which I'll go through in the next video. It's nearly 2 years ago the dry shaft failed. I was so disappointed at the start of summer in April 2023. Here is hoping for a better run this year. No progress on the boat, I'm afraid, but don't worry, there will be. I've just got my head thoroughly stuck in the helicopter fixing at the moment.